Hey, what's up guys? My name is Roma and in today's video we are going to talk about something called knowledge graphs. Knowledge graphs have been popular recently, right? And a lot of people are using it and some people are still struggling to understand what a real knowledge graph is, right? So in today's section, I'm going to talk about what a knowledge graph is, and we are going to utilize knowledge graph to solve a really nice problem. All right, without further ado, let's get started. So the problem that we have here, let's say you are an HR of the company, okay? And I work in a department, and our department needs people who can code in Python, okay? And you, like, if you're an HR, you might go like, okay, so we have, let's say how many CVs we've got here. Those are all CVs, okay? And if I get info, and then we can see we actually have around 5,000 CVs, almost 5,000 CVs, right? So it's really hard for a human being to go through them one by one. And we might be smart enough to solve this, and we might say, okay, we can actually, we can use a programming language to go through each one of them and tell the computer to find the CVs for the people who actually can code in Python. But there is a problem with that. Computers are fast, but still we are processing 5,000 files here. Like, let's say for each question, we have to wait for like hours to get the answer. It's not it's not a good solution. It's not an optimal solution in our case, right? So here we can make it faster by building a knowledge graph. Okay, graph is actually very fast, right? Graph database is totally different than SQL databases. We don't have to join any we don't have to join any tables and stuff like that. Like graph utilizes like the pointers. It points to data on other chunks of the memory, right? So in today's session, we are gonna see how we actually can build a knowledge graph, a graph which is knowledgeable, which stores the knowledge, and when we ask a question like on the spot, on the blink of an eye, it gives us the answer. Okay, how amazing is that, right? So I'm really excited for today's session, and without further ado, let's get started. All right. Before we start, actually, let me walk you through what we're gonna do today for this session. Okay, we are going to let me make myself a little bit smaller here. All right, can make it medium size. Yeah, that's a smaller version of me. All right, so given a CV, okay, we actually want to store the information of the CV in a graph database, right? And graph database actually works with nodes and the relationships, right? So if we take a look at CV, if we take a look at one of the CVs here, what might be our nodes and relationships? Like, for example, if I take a look at this CV, okay, this guy is a front-end developer. Okay, it's our person node. And this guy should have skills, right? If I go through it, this guy has skills like he can code in CSS, JavaScript, jQuery, and React, Angular, JS, and Ajax, and JSON, and so on and so forth, right? Experienced on CSS background and all those things. He can work with animations. Okay, so here I need to I need a schema to kind of store my graph, right? Like store my data in a graph way per se. And we need to kind of clean this, right? Like we are gonna be utilizing LLM, for example, to clean this. And always like for LLM there is a saying like garbage in, garbage out, right? So we have to work with the clean data. So we have to be cleaning our data before we actually train our model. So what we are going to do first, we are going to clean our data. So we are going to make some prompts. So those prompts are like, let's say ChatGPT, right? ChatGPT understands prompts. So we tell the model what to do, and the model will do it for us. Okay. So we are going to write some prompts. We will get to that in a bit. So don't worry if you don't understand what those prompts are. And we are gonna pass it to LLM model, which is from Google. And this LLM model is going to give us JSON for each prompt, okay? And we are going to kind of combine all those JSONs, and then we are going to kind of convert them into Cipher. Now, if once we have the Cipher is a query language that Neo4j understands, okay? I'm not gonna go into details of that, and I expect you to know all those things already, okay? If you don't know about Neo4j and how graph databases work, you can check out my another video. I think I made a video on that, and yeah, from here we have kind of a cipher code which can be um, inserted into the graph database. Okay, now once we have that, we have here, this is the key, this is what makes our process faster, right? Like just now I was saying, for each question, imagine like going through all those 5,000 files over and over again. That will be time consuming. But here, if we have a knowledge graph, it could be fast. We could ask for specific data, and the graph is going to give us the data that we need, and it's going to be really, really fast, because Neo4j is that's what it's famous for, right? And from there, we can connect something called LongChain. LongChain is a robot in the middle, you can see, and a user, let's say me, I ask a question. I can ask like how many people can code in Python, and this LongChain is going to do 5 following things for me, okay? So after I ask a question, and then it's going to translate my question into a cipher statement, okay? As I said, cipher is the language that Neo4j understands, so it's going to generate cipher chain, and it's going to be executed inside the database, and the database gives us the data that we need. So let's say all the information of the people who can code in Python or JavaScript, whatever we ask, and it's going to give us, and it's just plain data, and it's not English. So here at this point, what the robot is going to do is just to summarize all those results and translate them into natural language, okay, into English, and then it's going to answer us. Like, that's amazing, right? Like, you can ask how many people can code in Python, who has this skill, who went to that university, for example, who worked in that specific company, and the robot is gonna do it for us all. And like underneath the hood, like what is making this process faster is the knowledge graph, okay? And yeah, that's the outline of the today's session. And without like now at this point, let's go ahead and dive into the code. All right, here I have the workbench. I'm working with the I'm utilizing the Jupyter Lab of Google, and I'm using also some of their services. I'm gonna put myself here at the corner. All right, so we can get started with just knowing our Python version. Make sure we make sure that we are using the 3.8 version of Python. And here we are installing some dependencies, okay? We are installing the Google Cloud AI platform. We are using like Google's ChatGPT, let's say, okay? Google has like AI large language models that we will be utilizing from this package. And also the pipelines. Pipelines, usually they just, we have 5,000 CVs, right? What pipelines do, they just go through all those CVs and pass it to the AI. And we are using LongChain. LongChain is the robot that I was just talking about here. LongChain is this, so we are also installing that package. And yeah, after we install all those things, we are good to go, and we need to initialize our project ID and location. I created virtual machine for myself on Google Cloud, so we are going to give the details and the location as well. And here we are going to import Vertex AI from Google, okay? So we are initializing that, and we are giving our project ID and the location. Let's run that. And now at this point, we need to understand our nodes and the relationships, right? As I told before, Neo4j will not be able to understand those unstructured data, right? We need to kind of transfer those unstructured data into something called structured data. In our case, into Cipher schema. So this is going to be our schema. We have like 5 nodes and the relationships connected to them. So we have people, right? Some people have, like, all the people actually have skills. We will be storing all those skills in different separate node, and we are just pointing to those skills, right? And also the education. Like in like those people actually study at specific institutes or like universities, right? And they also have work experience background. They had positions and some specific companies. So that's gonna be the schema of the graph database. Okay, and here we are going to take a look at prompts. Okay, as machine learning, AI, and like all those large language models are taking over, we have to be able to generate prompts which are really specific and clear for the AI to understand. Okay, so what we are doing here, let me zoom in a little bit. We are actually telling the AI to extract information for the person node. Okay, so this is the person node, and we expect this node to have like role, ID, description, and then all those 3 properties. Okay, so we, for this prompt, we only care about those properties. All right, and we are telling the following to the LLM, like we are kind of restricting the LLM, because sometimes LLMs, they just generate some false information, or like they just come up with something on their own, right? So you kind of want to eliminate that. So we are kind of being specific, like first look for the person entity, type in the context, and extract the needed information defined. Let me actually copy this and put it to ChatGPT, okay? And let's see what we get from this prompt. So I'm gonna paste this prompt. So I need to plug in my CV here, okay? C text. So I'm going to go ahead and open one of the CVs that I have here. Okay, I'm gonna copy that and I'm gonna paste it here and just wait for the ChatGPT to give me the answer. All right, so it looks like ChatGPT LLM model is going to analyze the given CV and kind of helping me to translate unstructured data into something called structured data, right? So now this is in JSON. So as I told earlier, we are going to convert this JSON to into Cipher, which graph databases can understand, and then we can insert the data into our database. So yeah, this is basically what the prompt is doing. So we are going to take this JSON and we are going to run it in the database. All right, so this is the person. This is the person prompt, and we also have the position prompt here. Right, let me zoom out a little bit. We have the person prompt and the position prompt here, and also the skill prompt. So we are kind of telling the LLM to extract the information that we need from a given CV. All right, we are not actually running the code, but we are just defining those prompts. We are going to run it in a bit. All right, we will get there just in seconds. All right, here now the first function we are going to define is run text model. Okay, so this function is gonna take care of running all those things. Okay, what we do inside this function is just to use this text generation model. Okay, this function is going to actually get us the AI model that we need, LLM model that we need from Google. Okay, it's importing from Vertex AI, so we import that and we just predict, like we run the model here. All right, and we need to pass a couple of kind of arguments here, right? So it's going to take my project ID that I got from Google Cloud, and then the model name. So like we need to be specific, like which exactly model we are going to run. So we are running it here. We want the one called text bison, right? And this one, temperature, for example, is set to 0. So you can read the documentation about that, and we're not going to spend a lot of time understanding this. If the, for example, temperature is set to 0, then the large language model is not going to generate anything new. He will just restrict himself to the information that we have in our given CV. All right, so I'm gonna run that. Again, we are putting this run text model in another function, extract entities. And what this function is gonna take is only the prompt and tuned model name, okay? All right. So, and then here we are calling a function clean text. We wanna clean the text because our text is kind of messy here. As you can see, we have those symbols. We wanna get rid of them. So we need this function to clean up our text a little bit. Now here we are inserting the string. We are inserting the template from string. We need to be working with this because we don't want to write all the functions on our own. So we just utilize this string library and then just import the template. Here we have our sample queue, okay? Now this is going to be one CV, one sample CV. We're not gonna insert all those 5,000 CVs at once. We just get started with one and see how it goes, and then from there we can just loop through all those CVs in our folder. All right, and then next we are going to store all the prompts in a list. So we have like those 4 prompts for our nodes on top, and we are like getting ourselves a bucket, which is a dictionary with entities, and relationships as well. So we're gonna be storing all those nodes in entities and the relationships in a relationship. And we are going to loop through every single prompt, okay? We are calling it P. So we are cleaning the sample queue, getting rid of all those symbols, right? And we are substituting the sample queue into the prompt, right? So we have our prompt, and at this part, C text, just like I did here with ChatGPT, after C text, we are substituting, we are putting our data right here. So that's what the substitute function does. So we are putting the data there, and then it's going to run the function with the LLM, and it's going to get the answer. The answer is gonna look like something like this. So it's going to take the answer and just split and all those cleaning stuff, and at the end we will just have the entities and as well as the relationships extracted in our results variable. Let's just run that. It's gonna take some time. So LLM is kind of processing that. I'm just telling ChatGPT to kind of give me a clean data from my unstructured data. So once I have that, I'm gonna actually go ahead and append the relationships. Okay, so I have the person ID, and I want to kind of relate them into their own skills and like positions and also the education. And if we do that, and like we can see the results here. So we have the entities. You remember, like we had 2 buckets. We have the entities and also as well as the relationships here. Relationships and all those relationships. All of them are pointing to the data that we have here. So here, as you can see, we have what we did. Underneath the hood is this. Let me just walk you through them one by one. We had the sample data, right? And we had our prompts, and we injected our CV into the prompt, and we passed it to the LLM that we had, and LLM gave us all those JSON files, right? And what we did, we just combined all of those into one JSON file, so which is the results, right? So let me go ahead and get back to the code here. Now we have the JSON file, which is a structured data now, right? We kind of converted the unstructured data to structured data. Now we are going to kind of insert it into our database. Now, if I go to this is my Neo4j database. As you can see, this is empty. And now let's go ahead and insert something and see the data coming in. All right, now, so we are going to generate Cypher. First, we need to get the properties, right, of the nodes. So we're gonna get the properties and also the variable names and all those things. And after that, we are going to generate cipher. So from JSON, we are generating cipher. And if we do that, so we are basically doing this. We are getting the nodes and the relationships, and as well as like the properties attached to the nodes, okay? And with the cipher, after we generate the cipher, we will have like entity statements and relationship statements, okay? Now let me go ahead and run this. You can take a look. You can like read the code on your own. It's gonna take a lot of time to go line by line. And here we have like we call the generate cipher and we call my CV with the results, right? And it's going to kind of give us the entity cipher and relationship cipher. So as you can see now, this is a cipher language which Neo4j database can understand, okay? So from unstructured data, we went into this, and now we can just kind of like insert this data into our database. Neo4j actually offers something called driver, so we are utilizing that. We are calling that. So here, these are the details of my this database that I have here, but it's empty, so I'm going to initialize so that it knows where to insert the data that we have. And I'm gonna like connect, so it's connected to my database. Now from here I can run the query, okay, with the parameters that I have. So I don't have any parameters for now, so it's just empty. I'm just gonna run the query. And here, actually before loading the data, we are going to create constraints. Constraints in Neo4j, they make specific properties unique. They force them to be unique. If it's different, then it's gonna throw some errors. Now we define this run query function, so let's just call it here. So in entities cipher, right, we have entities. For each entity, we are going to run it and ingest it like to the database. All right, it's gonna take some time. Let's see. So after it inserts all these data, our data must be in our database. So now it completed. Let me go ahead and check. Actually, I don't have any relationships for now, so I'm gonna do match and return, and this should give me all the nodes that I have. All right, so looks like we inserted all those skills, and this looks like an education. As you can see, master's degree in some universities, and this one here, Bachelor of Arts. This guy looks like a developer. These are only the nodes. We don't have any relationships. Like when I ran this code, it gave me like no changes, no records, right? Which means it doesn't have any relationships because we didn't run the relationship cipher queries here. Now after we run this, let's wait for it for a while, and now we should have relationships, right? So they are pointing into different data in our database. Now if I run this, now we have the data connected, and we can just play around with this. So this developer has skill in JavaScript, Express.js, and all those things. All right, so we kind of inserted the data into our Neo4j, right? But it's only one sample data. We have a lot of like CVs in our folder, right? So we kind of need to create a pipeline and run them all, right? So we are going to create a pipeline which runs all of them and just kind of inserts it into the database. Now here we can run pipeline. This function basically takes like start parameter and count parameter. So we start from the first CV here. We start from the first CV, and for the beginning we just take like 10 of them, okay? Because it's gonna take time to insert them. Like for, as you can see, 100 files, it's going to take around from 30 to 45 minutes. So for now we just stick to 10 people, and I'm gonna pause the video here because it's gonna take some time, and I will get back to it in a minute. All right, so our pipeline finished running, and as you can see, I actually ran 10 more CVs. I ran from 0 to 10 and from 10 to 20. In total, now we have 20 CVs inserted in our database. And from here, what we have to do is the last step, which is actually connecting our database into the chatbot. Okay, utilizing long chain, of course. And let's get back to our code and do the last step. I'm really excited for this part anyway. So our long chain is gonna what long chain is gonna do for us is just to convert the statement into cipher and send a request to the database and get the data from the database and summarize the results and just kind of convert it into natural language that we can understand and answer. All right, so here we are initializing the long chain. So we are importing all those things from long chain library. So we are kind of training the model. We are giving this input, like kind of a template for our long chain so that it understands in the future what to give. Like for example, if there is a question called how many expert Java developers attend more than one universities, then the answer for this is going to be this query. And what this query does is just to kind of look for people who attended more than one university. I copied that. Let me just, here I tried it already, so I can just run it here and it says 1. So there is 1 person out of 20 people who attended more than one university and they can code in Java. All right, so it's generating it will generate the cipher for us. But with this, we're just training with the given template, all right? And we are doing some initialization, sorry. And then here we are initializing the graph, utilizing Neo4j graph here because they all support Neo4j. This long chain supports Neo4j. So if we run this, it's going to initialize our AI model, which will take English as an input and convert it into English and give us the results. For example, how many Pythonistas are there? So how many people can code in Python? And let's see what we get. So it's going to convert it into cipher and just give us the response. In our case, there is only 1 person who can code in Python at the moment. And here, voila, we actually got the data from the database. And here we can actually see it, right? At least 1. We can see the result, right? And to get to this step, what we did is just to take the unstructured data from CV and run the LLM model, giving prompts and just get the JSON. And with the JSON, we converted the JSON into cipher and ingested the data into our database. After we had the data, we connected the long chain into our database. Now we can ask questions in English, and we don't have to go through all those 5,000 files. Actually, in our case now we only have 20, but we can run the computer for a while, maybe 2 days or 1 day, to insert all those 5,000 files. And once we insert them all, it just on the spot, it's gonna give us the answer. How amazing is that, right? Now at the end, lastly, we are going to connect it into a chatbot. Our chatbot is gonna do, it's just gonna take some input, and here we are kind of initializing the chatbot. So we are utilizing conversation buffer memory from long chain again because it needs to have conversation, and it also needs to keep track of history of the chat. And in our case, we are using the LLM model called Code Bison, right? And you can give some the parameters. So temperature is set to 0 because we don't want the AI to be creative. We just want the data in our database, right? And we are calling the agent chain, and we are equaling it to chain. The chain is just coming from here, right? We initialized our model here. All right, and after that, we are just running. We are running the chatbot, so it will just give us the UI If I click that here, it's gonna open it up. I'm really excited for this part now. With the 20 CVs, let's see what the long chain will be able to answer. So my first question is, how many people can code in, let's say, JavaScript? And I think it's gonna give me the answer. At least 2 people can code in JavaScript, but this number is likely much higher. So now it can understand English and give us the answers from the CV that we inserted into the database, right? And I can actually, let's test this out, right? And when we call this function one more time, before we only had one, now it should be a lot more than that. It's gonna take some time. As you can see, now we have 548 nodes with 623 relationships. Now here we have a knowledge graph in our database. Let me make it bigger for you to be able to see. Now you can see they're all connected and we have our data in the database. And I'm actually curious. Let me actually go ahead and insert my name into the database. So I'm gonna insert myself and person with a name called Roma, and then I'm gonna give it a description of, let's say, someone who likes web programming and enjoys playing football. All right, so I'm going to insert that. Let me run this query. Now created one node, 2 set properties, added one label. Added one label or person. Okay. All right, now let's ask it. Do you know anyone whose name is Roma? Let's see what happens. So it's converting into cipher. Yes, I know Roma. Let's say, what does Roma do? So it's gonna access my description. Roma is a software engineer at Google. It's kind of getting creative at this point. But that's not what it is in the database, right? Can you tell me anything? Anything about Roma? This is happening because we didn't actually train the model well, because we only had, like, if I go back, we only had only like 3 questions and then 3 answers, right? We should give even hundred thousands of them for the model to be really smart and give the data that we want. So that's why it's getting creative, because it doesn't really know what I'm asking for, right? Now let's see with this prompt. It returned me empty string. Let's see, who is Roma? Oh, there you go. Now it's getting from the database, right? Roma is someone who likes web programming and enjoys playing football. So it's actually getting the data from the database, right? It's the one that I created. So I'm gonna merge this and return it at the end so that we can see. I don't want to create it because that will create duplicate data. Now it should return it to me. I don't know why it's taking so much time. But anyway, that's the point, right? Now we have 20 CVs in our database, and there is a model that can answer our English questions, right? We can even tell me people who have bachelor's degree. Bachelor's degree. It cannot be that smart to answer questions like that because we are not training it. So all right, now our model is good at questions like these: where do most candidates get educated? How many people have worked as a data science in San Francisco, for example? Now Now, here are people with bachelor's degree, so it's giving me the name of CVs. See, let's just insert that as well. 0 people have worked as a data scientist in San Francisco. Now it's kind of the data is valid here, right? And at least we have a robot who can answer our questions, and it's like real fast. Yeah, that's pretty much it for today's session, and I will see you in another session. Have a good one. Take care.